My name is Iurii, and I'm technical lead at Infinity Telecom. So we are service provider and telephony provider. So we're doing quite a lot of voice services and other services like internet connection. We do B2B. And today I'm gonna, as I already said, speak about scaling the VoIP infrastructure with custom MID-Registrars. So there are already a couple of interesting words like custom and MID-Registrars in 2025, but like it was interesting that probably last 2 years that topic raised quite a lot and regarding the MID-Registars itself, and it raised quite a lot in context that some small companies getting bigger and bigger, and then they want to scale this infrastructure, and it appears to be MID-Registars are one of the easiest way to begin with scaling the infrastructure without any, let's say, large changes in your already existing infrastructure, without any redevelopment, refactoring, and redoing the architectural investments, etc. So yeah, and today I'm gonna speak a little bit about that. So let's just summarize what is the MID-Registrar. So actually, the MID-Registrar itself, quite interesting, let's say, concept, right? Because it's not defined in any standard, so we don't have any actually standard about the MID-Registrar, but it's widely used in that or another scenario, let's say. It's kind of, in that case, like SBC. SBC is also something that we usually selling, but it's not exactly defined. So there is an RFC for the SBC, but it's quite wide. And MID-Registrars are quite tiny things. They operate with a particular methods and with a particular flow. And yeah, so the concept itself, quite simple. So it intercepts register requests, usually caches registrations locally for the faster lookup, and usually forwards registration to the main registrar. Does throttling sometimes not. It really depends. It's not an obligation, and it also acts as a local point of contact. So here I mean? So usually MID-Registrars set it up somewhere at the edge, like or SBC or MID-Registrar. So sometimes both, they sometimes mixed. And yeah, the usual flow, most common, is something like that. So we can see that there is a register flow on the one side from the UAC agent, UA agent, user agent client, sorry. Yeah, and MID-Registrar on the other side, and the second leg is a MID-Registrar and registrar. So, and in more or less in the both scenarios, it works like that, because user account client registers on the MID-Registrar, MID-Registrar registers on the registrar, and then MID-Registrar throttles attempts, because of we can increase expires interval for the particular contact and decrease it on the MID-Registrar, send it back to the user account client. So I think the common flow is pretty clear. There is nothing super advanced. Some scenarios was recommended by Daniel, I think, like a couple of years ago, and it's on the link in the list, so feel free to do. And he described actually two common scenarios which used quite widely. The first one is credential sharing scenario with authentication, location, registrar, and UAC modules, which we can implement on a Kamailio. And another one, credentials agnostic scenario by caching expires. So yeah, for the longer one, it's more or less combined with the schema I showed before. And here comes actually to the second interest part regarding naming of my presentation, custom MID-Registrar. So basically as Kamailio doesn't have any specific module for the MID-Registrar, any configuration of a Kamailio for the MID-Registrar becomes custom. So like you can, any one of us can do that custom implementation. And we go through first through those scenarios quite fast. I won't talk a lot about that, and then jump into the scaling part. So shared credentials implementation I took first, and here you can see nothing exactly new. So this pretty easy thing. So we have a route MID-Registrar which is going to be called from the request route, and 2 routes out and register, quite standard, quite common. It's in a default configuration of the Kamailio, more or less in the same view. So, and what we see that when the register comes, we actually act with the UAC functions, which just checks registration. If it exists in the UAC module, we just go to the route register, update it, and if expires 0, we just disable it. And if it's not, so we doing authentication and then the rest of the things. The benefit. So by the way, this is on the GitHub. I will share QR code at the end of the presentation, so you can look closely. So I won't stick too much on those right now. So in the resume of this approach, we can say that there are some benefits. So the registrar is protected from the spoofing unwanted traffic. The number of local points of contact can be easily extended by using multiple MID-Registrars. So we can set it up whatever we want. So we can set one in Europe, one in America, another one in Asia, and somehow to interact in the particular registrar which does all the heavy lifting. And it's a simple approach. So we actually nothing fundamentally new doing here. So just registrar and UAC models basically. So the disadvantages here comes with responsibility, I would say. So as MID-Registrar stays in the middle, and that actually doesn't propagate the exact contact to the register. So what it does, it have to handle forks. So for example, if we have multiple users with the same username, so we just move this to the responsibility of the MID-Registrar, and it's not often quite good solution, let's say, for billing purposes or for something like that, for the more clear routing as well. And another disadvantage, user credentials are propagated to 3 locations. Like by locations, I mean the domain. So it's a UAC module. We have to fill up the UAC table. Then subscriber table has to be filled as well. And what else? Registrar itself. And I won't say like that we have to give it to user. Otherwise, it won't work anyways. Yeah, and yet another scenario with credentials agnostic schema. So call flow is a little bit different. Let's say register flow, right? So we propagate register to registrar. Registrar answers for 1 or 407, whatever, stay there. Register comes with registration header, and we propagate it. Update expires and send back. So this schema basically works on a caching mechanism, let's say. That's how it looks like. So there are mainly a route register. We need to have an on-reply route. So this function on the Lua, I just prefer Lua instead of substrings and those things. So it does totally the same. It just rewrites expires. So don't mind about that. So yeah, the main route MID-Registrar called from has to be called from the request route. It does update with expires. Call the function which update expires if it exists in a contact header, and on the reply route actually caches answer. Here I made it on a source IP source port, but you can extend this. You can actually reuse a contact header to do this as well. And yeah, so the main function also stores the original contact into the AVP, and on the response we send in the original contact to the main to the UX. So UX knows that UAC knows that everything is fine. Here's registered, and we are able to do the throttling also just without large changes. So, and here, if we talk about the benefits and disadvantages, so there are no shared credentials, and actually there is no disadvantages. Like, it's pretty simple schema, which allows us just to propagate registrations and throttle them in quite easy way. Even we restart, for example, MID-Registrar, we just need to do this once again, cache, and go ahead. So yeah, here is a H table, all done, yeah, with after expires. So once it expires, we can re-authenticate on the registrar, for example, or source IP, source port changes, whatever. Yeah. So, but interesting part comes when we need to scale. So let's presume we're growing, and this most popular case, and customer or we as a service willing to extend amount of the registrar because of registrar in one node becomes heavy, let's say, or especially this is the case for the vendors software, because vendor software doesn't give us really many choices. Even with Asterisk and FreePBX, there are also not many choices, so we need to stick with the database, for example, or if we don't want to stick with database, and that's actually quite common case, we need somehow to handle this internally without any bringing to the infrastructure some new components and make it scalable, but in an easy way, let's say, begin with scale. And there are quite a lot of approaches. I would mention just two. The first one is spreading users between the registrars, for example. So that means separating, right? So we have registrar 1 with the users from 1,000 to 1,999, and the other users going to the next register, for example. And this schema brings interesting points. So there is like becoming more complicated logic, because of if we call to one register, we need to somehow, and user doesn't exist to this on this register, we need to call another registrar to find out somehow where it stays, where it sticks. We can use dispatcher to understand, so if the user not on this register but on another register, etc., etc. There are multiple ways which still gives us quite a lot of things to do on the MID-Registrar itself. So I mean, write logic, nobody likes write logic anywhere. We willing to set up, do apt-get install and make things work. So yeah, quite a lot of things. So in the benefit, so it's really easy to implement. We just copy register and put it to the new location, separate users. And for example, with schema with shared credentials, we can just change in a UAC-reg field proxy, proxy server. I don't remember exactly which one, but it just redirect a particular user to a particular register server, and that's it. And regarding the disadvantages, the registrars might not be aware of the location of all users. As I said before, routing logic becomes more complex, and routing logic is spread across the multiple services. So it's partially on the MID-Register, partially on the register. So all this makes things more complicated, let's say, to maintain. So it's possible, of course, but still. And another option is propagate users to all the registrars. So what I mean? I mean so that, for example, we have 2-3 registers, and we just copy them. So that means that each register is responsible for any user in the system. And we can actually just propagate these registers, registrate each user on each registrar, and then routing logic becomes less complicated. So we actually don't need think much about the routing logic, at least on the MID-Registrar. And yeah, so class 5 features mostly saved. Let's say in case of some complex solutions like queues, etc. Also, infrastructural changes, there is no needed infrastructural changes for this. The only disadvantage is more traffic within the internal network. But if we go deeper and we'll try to implement that, we find out that actually for the agnostic schema, it's becoming quite interesting. And why it's becoming quite interesting? Because we need to propagate registrar to each register request to each registrar, we find out that we need somehow to propagate authentication response and credentials to our users. And the problem here is no authentication response and authentication register request, because I just simplified schema, but it's here. Yeah, it just hides. Yeah. The thing, like, we need somehow to deal with authentication and somehow to gather all this authentication headers, authorization headers, let's say. And the problem is nonce, because nonce generated by each registrar separately, we can't control it, we can't anyhow deal with that, and yeah, nonce is a problem. Nonce is a nonsense here. Yeah, it's a problem. And nonce problem comes because of its part of the parameter response in authorization header. And UAC have to handle that. So to handle that, there are a couple of, not couple, but there is exactly one approach. And here I want to ask who can raise a hand who likes to read RFC, for example, at the mornings, SIP RFC at the mornings when you drink tea, for example, or coffee, or lay down before the sleep instead of book. Yeah. So the thing, like, I started to dig to investigate how I can handle that, and there is like actually already prepared solutions. So there are people smarter than us who's writing this. Yeah. So from the server perspective, it's already there. So actually, I won't read all this thing. It's 16.7 response processing, and proxy must aggregate responses before sharing. That means that it must aggregate information for the authentication responses and prepare to send it to UAC. So that means that response looks like that. Wildix, by the way, thank you for this response. I took it from your website and then a little bit adjusted. Yeah. So it becomes to that kind of response with a multiple 3W authenticate headers. And the second problem is how to handle it on the UAC, right? And here is how to handle it on the UAC. It's also in RFC, so we just need to dig it a little bit deeper. And UAC may deal with aggregated headers, so basically what it says. What is the problem with that? The problem with that I will say a little bit later. So let's take a look into how that's going to be implemented. It's going to be implemented in a really easy way. So that's under the hood dispatcher works. I didn't put it, but the route proxy register, what it does, it takes list of the registrars from the dispatcher and duplicates register request to all the registers. And route handle auth, what it does, it's actually gets the registers with the authentication header, with authorization header, sorry, and cuts off unneeded headers for particular response. That means that each register to each registrar has to come only with its own header. So on the user account side, we gathering that, and here's with decoupling. So that's what happened. Nothing specific. It based on realm. Based on realm. If realm is the same, you can cache. So there are quite a lot of mechanics. And this example doesn't include registers throttling, I mean, so it doesn't change expire, but it's just for simplification to have more attention on the details of this. And the summary of this approach actually quite good. But disadvantages of this, one disadvantage, but this disadvantage mostly breaks everything. So actually, this quite limited support of this required features of this particular paragraph of the RFC. Yeah, and it's quite limited support of the devices. I don't know, SNOM devices do they support this? And I remember that Zoiper probably supports, I don't remember, I tested Zoiper. I know that someone from Zoiper here, at least he was yesterday. But where it comes actually to be true, to be a good solution, to the clients which we are control. Like we are in control, or we're writing our own. So Pascom guys probably gonna be happy with that because of they writing their own client based on the PJC, but still can adjust the code. And for gateway, WebRTC gateway, that's pretty much good solution. So because we can control it quite easily. We all know that JavaScript developers aren't real developers. Yeah. I'm joking, yeah. So yeah, that's quite easy to do in that case. Or if you have a hardware or software clients which are actually good to go with that and support that feature. But how we gonna deal with the rest of the things which aren't support, right? So we still need to scale up. We still have to have some mechanics to make it good. So and there is like and yet another approach which comes actually from the shared credentials distribution, and basically. We can use even the first schema which I shown, which uses UAC and registrar. We just can duplicate in a UACREC records in a database, and UACREC gonna connect us to all needed registers. There is a way, just we need to do a little bit more handling regarding how to propagate credentials to USC, to subscriber, etc. Still doable, but yeah, we can simplify that. How to simplify that? We can actually propagate existing register to still propagate, and but still authenticate on the MID-Registrar. So instead of using UAC module, we can do it by ourselves. How to do that? To do that, we have first to implement. So route auth is a standard route auth. There is nothing new. So MID-Registrar does again spreading across the register nodes based on dispatcher or whatever mechanics you're gonna use, whatever mechanism you will choose, whatever additional module. And the interesting part here that we need somehow to handle those authenticate responses here. And probably the first which comes on top of your mind is a failure route, but it doesn't. So it will handle only one first arrived, the other it won't, just because of failure route acts on the transaction layer, and the other transactions not gonna be for other later transactions, it won't be called. So that's why here we use term branch failure route. It's TMX, it's nothing new, so it's 7th route. It's maybe not so often used as a failure route, so we can use term branch failure and handle there. So to handle there, we need to implement some kind of logic. You see here is escaped parameter passed to the database. It's very important from the yesterday things we know now. Yeah, so we just select password from the subscriber. We use AVPs, which in a UAC propagated via the parameters. UAC can propagate parameters, and we can do that authentication that kind. And we call UAC auth function, which does for us heavy lifting and creates authentication authentication header, and passes actually register to the chosen registrar. There is only one thing which I have to mention because of it won't work on a, let's say, on the Kamailios later than 5.7 probably. Yeah, older than 5.7.6. Because of that was need heavy development to do quite a lot of stuff. So I've done this. So this is my commit. You can see there's quite a lot of code and quite a lot of breaking changes. Yeah, that's what sarcasm, of course. Yeah, I just added event road here to be executed for that function. So actually for all functions for the UAC module. Yeah, so all of them to be executed, sorry, in the event road. And yeah, so here we are. Daniel very carefully looked at that, approved that after like quite a lot of time. Yeah. So yeah, and then it's possible. So the summary here quite interesting. Like disadvantages, we still have to propagate credentials. It's not really so much that we need to do this with UX, so it's only one time to the subscriber, but still. But in general, it works for everything, for every device, I would say. And takeaways. The takeaways here is that it's easy to implement with Kamailio, even though the setup is actually custom. Yeah, it helps scale services without requiring major infrastructure changes. So actually, no changes at all if we don't use database to share credentials between registers. Enables cost-effective service scaling, to be honest, because that's going to be done in one day. So not one day, it's kind of couple of hours of work. So you install Kamailio, do that. And it's highly flexible. It doesn't rely on some heavily specific modules, some heavily specific development. So yeah, we can say that Kamailio has four MID-Registrar modules. Yeah. Thank you for your attention, questions, and link for the snippets if you wish to look into it.
Thank you, Iurii. Okay, quick questions now. We have here in the back.
How? Sorry. Okay. So how do you handle the disappearing UAs? For example, mobile SIP clients, they can, disconnect it from internet without unregistering.
Yeah.
So they will remain remain available for the registrar, and any call to them would have problems.
Generally, for those cases, better to use TCP, and once request comes, you just check if there is still pointer on the connection. If it's not, so it's TCP ops module allows you to do that. You just check. If not, so you just say 404.
Question here.
Oh yeah, thank you. Do you use this MID-Registrar for TLS, and do you change from TLS to UDP before changing?
Before propagating.
Yeah.
Yeah, that's like no any other difference when you use usual proxies which do this heavy lifting. That's why I mentioned WebRTC. So basically, you can connect WebRTC devices and then propagate to UDP for your services. There is no limitation for that. So it's
yeah. Okay. So Tim, can you come and set up? We have one more question was already here. So you will answer. Just give the microphone so Tim gets set up. Microphone also. Your microphone.
Yeah. Microphone. I have to give it back. Yeah. Indeed.
The quick one. It's another one there.
Just another question is, what is the you think is the main, let's say, difference or maybe competitive advantage of this solution comparing to another similar solution?
If I understood you properly regarding another similar solution, there is a problem that that solution actually, in case of module, because it has particular module, it implements only one scenario, basically, and you can do any other scenarios. And here you can do whatever you want. So that's why I name it custom, because it's custom. You can do everything.
Thanks a lot.
Okay, so you still want a quick one, or you catch after?
Okay. Here.
Then,
No,
okay.
I have a question, but I can ask.
You can ask it here.
We do this.
Okay, thank you, Iurii.